And Sheena Visram.
You can call me that. It's mine.
Who is a PhD student of mine, fourth year. And I'm sure they'll introduce themselves, but they've been working together for a number of years on this amazing project, and it has just gathered momentum each year. It just keeps going and going. It's very exciting at the point where it is at now, and there are each year hundreds of students get involved in it. So without further ado, I welcome you both.
Thank you very much. Thank you. Okay, so yes, I'm Professor Dean Mohamedally and Sheena Visram. We have been working on many projects for the year over the years. We have been dealing with things across the NHS and looking at healthcare, digital health, and how our well-being in the future might look like. So there's always been storytelling behind the works that we have investigated. MotionInput happened with 4 members of us. So there was Sheena and I, my wife Atia, who's a GP in the NHS, and Professor Graham Roberts, who's in our teaching group. And it really kicked off over COVID in the first wave. We were investigating, when the first lockdown happened, a protocol called News 2, which is a first range triage process for how doctors and clinicians would engage with the public. And a lot of the things that they would have to do were tangible. You had to hold a person's arm to put a blood pressure cuff on. You had to put sensors on them, and then you had to clean the, oh, you've got an echo there. You had to clean hygienically all of the sensors, etc. And we needed to figure out a range of technologies that could help make things touchless. Because if the vaccine had failed, where would we be today in shared computing spaces, in hospital wards, in clinical settings, even going into McDonald's? You've got the touchscreen that's just not nice. So there are a number of reasons for why touchless technologies do have a place in society. And Sheena, in her research under Professor Yvonne Rogers, has been looking at healthcare and clinical reach. And she's done a very expansive study on that. And so she will cover the latter half of this presentation. I'm only familiar with the medical terminology because of my wife and Sheena encouraging me on things that need to happen in healthcare. But my background is actually gaming, and my interest point is in health and well-being for children. And as you get older, when illnesses happen, people who are in stroke recovery, for physiotherapy, and simply old age, what we call humanizing technologies. So my PhD background 25 years ago was in HCI. I was at the Center for HCI Design, and I looked at things in a realm called constructionism, how tangibleness, objectiveness could be manipulated to learn, to grow with. And so one of the things that I picked up on during the COVID wave with Sheena and Atia and Graham was that there's a whole realm in entertainment and gaming where you see little children imitating and mocking movements of things that they like doing, like flying a plane or driving a car, or Spider-Man doing their movements. They see them playing in the playground. So we started on this journey to create a software suite that could help make things touchless. And where we're at today is MotionInput 3, and we have very significant partnerships. At Microsoft, there are members of the Xbox team, the Microsoft Teams team, the Visual Studio team. They have all been assisting our students working on projects in this domain. At Intel, we have core engineering with their primary leads for engineering, Intel NUCs, for this is little box computers, computer vision with OpenVINO, and a number of optimizing technologies within the OpenVINO space. And at IBM, we have mentors who have been looking at design thinking, how to capture true requirements modeled in clinical settings and real world settings. So it's not the fact that we can make it touchless, it's more the fact that does it suit being touchless, if that makes sense. And there have been many companies that have come out with technologies before that do these things. for some reason that are mostly business oriented, they kind of killed off their own product stacks. Like PlayStation had the iToy, Kinect from Microsoft was very successful. It was bundled with every Xbox. Leap Motions have been around. When Maplin was around, it was one of their best-seller devices, so Leap Motion devices. Right now, I want to buy a Leap Motion device, and it's quite hard. You have to find specialist ordering sites to order these things. So they're not yet back in the mainstream, I guess. But the technologies are evolving, AI is evolving, computer vision is evolving, things are moving at a rapid pace, and where we're heading is algorithmically looking at computer vision, natural language processing, gesture recognition technologies, and packaging them in different combinations that suit user needs. And so MotionInput isn't one software to be deployed as is. It's an architecture. It's an architecture that supports many different models and combinations of models. So with Microsoft's blessing, we were actually the first to publish Windows Store apps. On behalf of UCL, we went through 9 months of UCL Legal, UCL Communications, Media and Marketing to get the branding right, to get the system in place. And now we have proved a pathway for UCL to deploy software on a global marketplace. This is an opportunity for all of you as you're working on your projects and your research. We have now got a full framework, fully fleshed out and documented for how to reach. Because previously, UCL kind of let go of the reins of the Apple App Store and the Google Play Store, that people would be supporting the apps themselves and there wouldn't be any infrastructure in place. But in order to succeed in what we're trying to do here, to make PCs touchless, we had to go big and think big. So yeah, this is a teaching-led project. Now, this is quite surreal for many people to understand. I'm not a research staff. I'm not holding any grants. I've helped many other researchers get grants. We've had several really big projects. Project Physio is one of the biggest, with cystic fibrosis treatments and IoT devices at Institute for Child Health. But I run a program here at UCL called the Industry Exchange Network. I don't know if you've heard of that, but it's our framework for how we engage industry with students in real-world requirements to build out first-generation prototypes and proof of concepts. So in the design cycle, once you've got your requirements model and you've got your first inkling of this is the idea that takes it one step further, you're going to need R&D developers. Now, back in my day when I did HCI, I was the only engineer amongst a field of psychologists and sociologists and statisticians. And left, right, and center, I was being pulled. I was saying, you know, they all want something from that engineer. Now it's more of a pairing. When you've got a sidekick, and you've got a developer, and you have an AI as another sidekick, you can be empowered. You can build out things that you couldn't envision before. And so this software is a demonstration of that, that we're using just a regular laptop with a regular webcam, and we're analyzing your speech simultaneously with your hands and your face and full body movements, with the choices that you have selected for how you want a system to interact with you. Essentially, how you move and how you interact are the measures by which a computer should be navigated, not you being forced to type QWERTY keyboards or you being forced to know the double click, right click, which click is it? I don't know what click. I had a fight with the Microsoft Cortana team just to get the word click to be recognized. We were the first to do that. In our system, when you run it, you say click, you say double click, you say right click. It does what it says on a tin. And it does so without training, does so without any other guidance. It's available and it's a service. So there's massive impacts of that. If it knows your voice and it can detect your voice print and you're a doctor in a clinical setting, there you go. You walk up to a computer screen and you just navigate it without touching it. But we've had over 150 students, and I just need to reflect on that. They are the best students I could possibly imagine. Yes, I'm biased. I teach at UCL, but like you've got Liv here, you've got Mohsin here. They are my undergrads. They have done phenomenal duties above and beyond what I have expected out of projects. And yeah, we've taken 9 open source AI models. We have baked them into a tin. We've put them in such a way that you can extrapolate future projects from it. And we have made it possible that it looks very carefully at the workflow user mechanics for how to deploy. Because if this requires you to go into GitHub and compile it and get someone to resource it and set up a server and put in user credentials for Azure, or know how to do a .NET patch and how to build out a service line as a SaaS, all of these technicalities, no user is going to do that. We proved, Sheena and I proved, we can get it to run in a GP practice and in a clinic without needing .NET patches or administrator rights. We have that pathway as part of this. So UCL Business have come on board to partner with us, and we have free for personal end user license on this, but we want to start licensing it to companies, and so that's the next stage of this work. Not all superheroes wear capes. This has always been the standing message, but all of these kids, all of them, they are our pride and joy. And I can't express. I mean, Sigma's doing a PhD at Cambridge. She ported this to the Raspberry Pi. She optimized the frame rates to get at least 18 frames per second, so it's smooth enough for a child to navigate touchlessly on a Raspberry Pi. The first thing they did with it was run Scratch. Raspberry Pi Foundation went nuts over this. And Samuel is now at Meta. He's on speech processing. He's the one that showed us how we can make multilingual opportunities in an open framework become part of any system, to the point where we now have one of the apps in MotionInput is called Speech Hotkeys, and it lets you define the phrasing, the words that you want to say, to just issue a keyboard shortcut. If you want to use a swear word, you use a swear word. Whatever your phrasing you want, you can redefine all of the keyboard shortcuts and mechanics that are in your existing applications. So what we're talking about here is a technology layer that replaces the keyboard, mouse, and joypad without rewriting your software, observing what the utilization of that software and user interaction layers are, and unveiling through APIs what its potential targets of use could be. And in the future, it will have further AI evaluation to better improve what we mean by human intent. The students themselves have been heavily recognized by industry. Steve Bethich in 1991 wrote Mouse Ballistics for Microsoft. He made it his work part of the Windows XP operating system, and he is the current director of Surface and Windows. He runs the Windows group. Professor Bill Buxton is a legend in our HCI field. Yvonne is a friend, and he invented multi-touch in 1984. He was at Silicon Graphics as a CTO when they produced Jurassic Park. He led the Wacom contracting for digital pens. And they came and they had a field day with the students. They were loving it. They were playing with it, and they were showing what does it mean to have digital inking in the air. So a Surface pen requires force to be pressed on a surface. Our digital inking in the air solution, the algorithms are compensating for your depth, your hand distance away from a webcam, and translating that depth into the same passageway of code that a Surface pen would drop ink. So you can use a toothbrush or a stick to draw as a Surface compliant app. Karen Walker and John Coyne were in charge of brand and marketing at Intel, and they've been doing a massive amount of outreach. The new group that have taken over, they're meeting with us on Friday to talk about how we take it further with Intel branding on devices. You would see future Intel NUCs and little computers that have touchless capabilities that you don't need a keyboard. IBM as well, looking at more of the architecting of services and consulting. They've just announced Watson X. They've asked us, can we have a brokered bridge between MotionInput and Watson X to leverage conversational AI with touchless behaviors. And Dr. David Reeves is a great friend of ours. He's now joined our team. So he's actually one of the mentors in the MotionInput project. He's the former CEO of PlayStation. So if you ever played PlayStation 1, 2, and 3, he loves games, and he's a part of our group now. So we're not doing this on our own. We have now got ties to the digital accessibility team. Anelia and Mohsin are connected to them as well. So we're looking at cross-site testing for the university. If you've got users with accessibility needs that would like to trial the works with it. NHS England, Gosh Drive, the ALS M&D Association. VR Therapies is very interesting because that's run by a nurse who's been teaching the elderly and users with certain conditions to use VR headsets to get experiential awareness of, here's a remote holiday, here's what it's like to go around Rome or see a beach. And, she's looking after unique domains as a nurse. So definitely someone that I'd recommend that you contact if you wanted to do studies with. And the Institute for Child Health, and more recently, Cloudsley School, where we're heading tomorrow to speak to some school teachers. So yeah, from my part, population health, Many of us are getting dowager's necks, we're getting hunchback, we're not moving enough, we're not out and about enough. Keyboards and computer screens, sitting down all day, remote working, these things are going to affect our longevity and maybe even how we evolve in the future. So making things touchless is also part of that. And so, yeah, the three themes that we focused on was touchless computing, computer vision, and motion-based gaming. And I think it's time that I shut up and show you a video. Sorry. If I can get to it. Okay. Sorry, how do I? Technical difficulty here. Oh, it's still projecting that. Okay. Sorry. So this is just some of the current features that are in our package. That last clip that you saw a complete override of Microsoft Clip Jamp, which has been seen by the Microsoft Accessibility team, and it does actually have more capabilities than their voice commands have currently. It means that combinations.
Is the
Whoops,
VTR
sorry, one second.
mathematically the best
Sorry.
from ever,
Sorry.
or is it just more of the same? Stick around.
Sorry, adverts. So yeah, the combinations that users want to choose are still being fleshed out. They are fresh projects to be created from this. You saw Liv running as Sonic the Hedgehog. She'll show you a demo later on playing Sackboy. You're moving your legs to move a character forward. It's just taking over the up key. But the latency is there. The gameplay is fine. You can stop at an edge. You can stop at a cliff. And actioning events, you saw the swimming. Those of you that like Street Fighter, we do have a model of Street Fighter Hadoukens going on. Whatever the gameplay mechanics of the storytelling to envelop the characterization in these games, if you're playing Tomb Raider or Indiana Jones and you want to, whip a tree or something, you have the ability to make the gesture shapes that you want, and the calculation smoothing is there to make it robust enough for multiple different sizes and dimensions of users. So there's a lot of opportunities in this. And I think that those of you that are in the realm of accessibility, you're going to have a field day with this. If I just show you another clip, this is one of our legends in our team. This was Alex. And yeah, if you can imagine a person that's been suddenly restrained and they can't do things with their hands anymore, this gives them their freedom to get back into the interaction states that they would want to access. If they were an architect and they had a stroke, they could still use AutoCAD. You've got enough of the methods and models there to be able to enable that interaction. So yeah, this comes back to the storytelling of what can a person do and how do you relay that back into a system at the speed, not of future apps, but existing software and things that you already know are in your domain. Okay, I'm going to hand over now to Sheena. I've talked too much. Yeah, thank you.
Did you want me to do the other one? Just take that, just- Thank you. Is that all right? And then this one just further below. Amazing. Thank you for your patience whilst we're handing over. Dean, I always just sit and watch presentations about motion input and I'm filled with excitement and such joy. And it reminds me how busy the last few years have been. And so in part of what I would like to do is rewind a little bit. Right now, motion input, it is a sophisticated module of different natural user interface interactions. That's what it is now. But in actual fact, I want to take you back to the pandemic period. And that's when my research was just getting going. And Von will know we had a plan and then things changed. And I had to adapt to that change. And so a part of what we developed out in motion input was based upon the urgency of what that pandemic period commanded from healthcare professionals that I was working with. To introduce myself to you who I haven't met, there are a handful of unfamiliar faces who I look forward to getting to know a little bit later. My name is Sheena Visram. I've worked in healthcare for 20 years, seen so many changes across the landscape during that time. And in the last 4 years, had a real privilege of spending time and learning from Yvonne. I come from a deeply clinical environment, even where I've worked in technology adoption. And a huge part of that has been about what the clinicians require and what some of the clinical affordances may well be. By getting to know the team here at UCLIC, I've had a chance to reshift my thinking, really challenge some of the assumptions that I've made. And I really hope that some of the thinking that's gone into motion input has been influenced by that, inspired by some of that thinking too. So I work out of a place called Drive at Great Ormond Street Hospital for Children. There are very few places in the world like this, and I love being able to say that. Alongside Yvonne, my second supervisor is Professor Neil Sabir, and he's a director out of Drive. It exists as a go-to place for building out technology and trying to work on projects with staff. It sits on site at a hospital. You don't get that. It's a rarity to have this dedicated space for innovation. It's bright, it's got clean lines, it's inspiring. I started my PhD doing lots of stuff in person out of Drive. To balance out the fun and excitement of what it is to work out of Drive, there's also a very serious side to things. It sits on site at a children's hospital. In fact, it sits on site at one of the most prestigious children's hospitals in the world, where they deal with rare diseases. Every day we talk about safety, we talk about clinical safety, the impact to care. There's a really serious undertone. And part of the challenge is marrying up how exciting new technologies can be, but also respect the boundaries that do exist within that infrastructure of care and providing safe care to some of the sickest children. My clinical experience when I worked in healthcare was working in intensive care. So where patients required feeding tubes either into their gut or intravenously and to feed them when they couldn't eat and drink usually. So for example, on an intensive care unit where patients were sedated, they were asleep for a long period of time. And so I completely understand how overwhelming that can be to actually be wrapped up into an intensive care unit, providing care on a day-to-day basis, where the safety of a patient is paramount. Infection control and conversations about infection control are paramount. There are lots of policies, procedures, which make change really, really challenging. And so to have a really exciting raft of new technologies that might make a difference to these very complicated environments, well, those conversations take time and they have to be crafted in a certain way with bucket loads of empathy and respect, having a broad stakeholder group, cutting out a lot of the jargon. I've had to learn to talk simply, to talk slower, to give people time just to think. Now, touchless computing, I know Dean touched on this a while back, that it's not entirely new. Touchless computing or touchless interactions have existed. I think the first papers I read came through Project Natal in 2010. And soon after, teams from Microsoft, through HCI, you'll know Kentano O'Hara, and I've had a wonderful chance to get to know him, to learn about his research in 2014, 2016, where he went into operating theatres to try and understand whether surgeons could make good use of a Kinect to be able to map out how their hands might move to interact with electronic records at specific times during operations. The motivation there was that, well, surgeons need to be able to take off, don and doff, we call that, take off all of their protective equipment and their gloves to then get to a computer to type a few things in or shout across the room for somebody else to do it. How could you make that a little bit more seamless? And so there were a number of teams who worked within this environment, and most of the research that's taken place using these kind of gesture-based interactions have been within operating theatres, either within operating theatres or into a field called interventional radiology. In fact, a systematic review published only in 2019 by a team out in Ireland, Cronin and Doherty, looked at 41 of these studies. And so the reason why I mention this is that we weren't revisiting or taking on a problem that never existed before. This is something that had always existed. It was something that had been investigated over many years. We were taking a fresh look at it, and our approach was slightly different. It was different in a few ways. Dean, you mentioned that rather than requiring expensive equipment and lots of training to set up an infrastructure and get permissions, I had a really joyful opening conversation with clinical staff because I could ask them to imagine using a shared computer with a low latency webcam, the kind you'd see on your laptop or attached onto your PC, without needing to use your keyboard and mouse. In fact, I joked, I said, imagine if you came in on Monday and I'd removed all the keyboard and mice on the ward, what do you do? And everyone was up in arms. I don't know what we would do. And I just asked them to imagine. Imagine if you could use hand gestures to interact with your electronic patient record. Imagine if you could turn your face to turn pages, or be able to interact with that interface using kind of another type of gesture. Imagine if we could be a little bit more joyful and fun, doing a whole body movement to be able to interact with a system of sorts. And that's how the conversation started. It was very much so about imagining what could be, but also not with having to think about new equipment and cost and whether it would be allowed, using the equipment that you already have. What can we do that's different and feels more natural with the equipment you already have? And that was a real motivation for the work that I was involved with. During the pandemic period, there was a revived interest in touchless computing. If I had Neil here, he would be the first to say that very suddenly staff were aware of the fact that they needed to be wearing protective equipment in kind of in all environments, rather than in some of the specialized environments where you would wear gloves, you might wear a face mask, you might wear a gown. They were having to don and doff this personal protective equipment in many more environments. Certain environments that even as a clinician, I could get access to very easily. Well, suddenly they became really restricted. For me, that was a real shock. I suddenly didn't have the permission to access all of these places that I felt very much so at home in. I understood better what it must be like to be an engineer or a designer or somebody working in industry with great ideas, but who just couldn't get their foot through the door. And so the environment was different. It was very serious for a long time. It was incredibly tough to research. I needed to have some really long conversations with both Yvonne and Neil about whether my position as a clinician would be to return to the clinical environment, or in fact, whether my research might pivot to make a meaningful difference, even if it be to understand an opportunity or a problem that exists better. And it was the latter that I chose. And that's where my research, which broadly looks at how we can work with clinical staff to have meaningful conversations about new technologies and how they could be appropriated and adopted into a healthcare environment, focused in and honed in part into touchless computing, because there was suddenly more of an interest to have a conversation about not touching equipment and people and things in a way that I hadn't seen before. And I kind of want to say that this was an unprecedented time. Yvonne, you may recall that you'd said to me, do you know what, Sheena, in years down the line, when you're writing this up, we won't be talking about the pandemic. It will be the past. And it feels like we're all sitting here together today. Well, you know, a year ago, that wasn't the case. In an actual fact, we're not just talking about the pandemic period, but at that point in time, it was unprecedented. And I couldn't have imagined anything different. I had to be really respectful to staff who were afraid of how they would care for their patients in new and different ways, and treating patients from afar, getting access to face masks and communicating well with one another, getting access to kind of gowns in a way in which not everybody had needed to use, wearing gloves everywhere and all the time and constantly having to take them off, having hand gel everywhere. That was just one of those things. We were constantly cleaning ourselves, cleaning the equipment that we were, kind of the environment that we were working within, and having far many more conversations about infection prevention. And that's the realm that it falls under. And so as somebody researching within that space, wanting to inspire people at a very difficult time about a new technology, I had to take a much broader view of that environment and be really respectful to some of the restrictions that existed. I took time to really listen and observe and notice in a way I couldn't have done had I been working clinically on team behaviors. And Dean, you alluded a little bit to this, but also customizing what non-touch technologies might be able to offer during clinical interactions. And it's fantastic that I could say at the very beginning, guys, let's use gestures to do this, 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 and this. I had to listen to everybody saying, well, wait a minute, what if I want to do this, this, this instead? What if I want to talk? What if I want to use my face? What if the hand gestures don't pick up the things that I require? Does it work at the distance that I'll be, kind of a distance from the laptop or the webcam? These were all the conversations that they flooded out, questions after question after question. And so what we had to really define was, what is motion input? And the first raft and the first version looked very different to version 2. That looks so incredibly different to version 3. And having you guys from the Team 3, version 3 team, it's amazing to have you here, because you are working at a high level with an architecture that's been rewritten. But the journey is, I guess, where some of the excitement sits, because that wouldn't have existed had we not had version 1. And I still remember working with one student, Emil, and I'd said to him, let's figure out, hand gestures at a desk. And he'd started with a glove with little kind of colored points on. That's where motion input started. Where we are right now is because we've taken an iterative process and we've learned every step of the way. We've also, from team to team to team over every, we've been really open and shared all of that code, happy to rewrite, to rebuild, to ask, to learn, to say this does work, this doesn't work. Dean, you'll talk flawlessly about how we combine hand gestures with speech. Well, a lot of that came from feedback from surgeons in the operating theatre who'd said, well, wait a minute, I just need to say that rather than try and figuring this out. How do you combine the two so that it's personalized to a specific use case? And that's been some of the learning that I've had to learn and listen, to understand, and learn not to assume, to know what a clinical environment and the clinicians who work within that environment, what they need. So this is a short clip of some time I spent in a neonatal intensive care unit. Now, the environment is the neonatal intensive care unit, but it's not a real session. It's what we would describe as a clinical simulation. So it's a team who work together with a kind of a dummy, if you like, as a baby, but which responds to some of the mechanics of the equipment, and without me there with a 360 camera. What this allowed for me to do was actually start exploring an environment that was described to me as being very complex and hard to innovate in. I had the chance to understand some of the hotspots of touch. What did people touch without getting in the way and being there? Did everyone touch the same thing? How often might they touch that bit of equipment? What would they touch next? What was avoidable from touch patterns? To me, that was an important conversation. Perhaps even more so important, what was non-avoidable touch? If I need to care and touch for this baby and assess them in the best way possible, and that required me touching them, well, we're not going to say, let's make that hands-free. It's respecting the constraints of that environment and what it is to provide compassionate care. It also allowed for me to have a little think about some of the optimal conditions to consider if we wanted to build and implement a touchless technology within a complicated space. Now, that work within the neonatal intensive care unit, we managed to publish as a kind of a brief communication in the Journal of Perinatology, because we were also really keen. I was really keen to start having this conversation. How do you access very hard to reach environments or hardly reached environments within healthcare? Rather than talking about it as a challenge, I wanted to see it as an opportunity, even if it be without me being there in person, but being able to ask the staff to install kind of a webcam of sorts. We used a 360 camera in this circumstance to get a much broader view of the environment so that I could actually move around from afar and actually inspect and interrogate that space and a use case. How's that interlinked with motion input, you might say? Well, some of what I'd learned through that, I was then able to translate to what a new touchless technology could afford to offer that was different. It also meant, and I can't underplay this in healthcare, for any of you who've worked within healthcare, I know, Layla, Julia, you've had times you've worked with clinicians, those relationships and building foundations of trust, they don't happen overnight. The time I spent working with clinical simulation and respecting what a team might require in a complex environment, albeit a simulation, meant they wanted to have more conversations. And in fact, they told their friends about it too. And so the next thing I knew is there were surgeons knocking on my door saying, well, I hear you're doing things with touchless computing. We want to have a go too. What that meant is that by the time we'd built out version 2, we could interact with surgeons. We maintained our relationship with the clinical simulation team. For my PhD, it meant that I could take this giant leap back and say, well, we could talk lots about the finer details of usability and UX, but actually, what are the requirements to create an environment where across disciplines, people can innovate better? How can we make this possible? You'll see in the picture at the bottom, that's Stefano. He's one of our cardiac surgeons. And we set up what would be the equivalent of a hospital bed. He'd said, you know, if I'm operating, there's a certain space I would require between a laptop and I. And so we set up MotionInput with a number of use cases. With everything that we did, we didn't use patient data. We didn't access patients. It was the purpose was to emulate as best as we could do. So the picture you'll see that's microdicom. It has a number of examples of what scans might look like. And what we did is we launched MotionInput on a laptop very similar to one that he might have access to. We set it up within the clinical simulation suite. We used the double cameras that they have in that room to teach him how to use MotionInput and ask him what he might find it useful for. He'd said, you know what, oh, having this on my slave screen in the operating theatre, well, that would be really helpful. During an operation, sometimes I need to look at some of the scans and pull up radiology in a system that we have installed within the operating theatres. I might find it useful to annotate that or make comments or even communicate with my team members. Can I do that? And so in actual fact, one of the things that we tried out with him at a good distance of just under a meter away, using one hand, which kind of was a hand that he preferred to use based on the setup of his theatres, was to see if he could draw on a scan and how easy he might find that. And so this is customizing what MotionInput could do to be able to add value within his complicated working environment. That doesn't mean he'll be using it tomorrow, but it did spark and inspire conversation about how touchless computing might have a place within an environment that's already been researched a great deal, as I'd mentioned to you, of the systematic review that's been conducted on touchless computing. 3/4 of those studies are in operating theatres. The question I asked was, well, why is it not mainstreamed? And there were lots of reasons behind why, but I suspect one of the reasons is that technology needed to advance a little bit. It was expensive to install the technology of its time. But the time spent working with clinicians to customize this technology to what they needed and what they would seek value in, perhaps was underplayed a little bit. And I'd hope to invest a little bit more of that. Now, you'll often hear about operating theatres, and even you'll have seen that picture of Drive. Clean lines, it's gorgeous. It's ever so flawless in how it's set up. It's a new space built out for that reason. Even in the clinical simulation suite, it's flawless and it's clean. The reality, and I know this from having done lots of work, improvement work with WHO checklists and such in operating theatres, they're busy spaces. There's a lot of other equipment in operating theatres. That's one of the things that we next need to really contend with, that if operating theatres had an awful lot of space, that would be absolutely fine. One of the greatest challenges, and this is what the team of surgeons said to me, they said that, you know, the one thing we can't handle is any more equipment in this space, because it almost feels like we're tripping over cables at times. What we require is just to have something that is integrated as part of the setup that we already have. And so what that might translate to is they use stores where they turn on and off their lighting and move their cameras. How by integrating touchless interactions as part of that? They already have a setup where if you're doing laparoscopic surgery, which is minimally invasive surgery, which often uses a camera to look at the kind of the insides of a person, if I can put it kind of in that way, that will often show on a screen above the operating table. Well, the surgeons often have a second screen, and they describe that as a slave screen. They said, you know what, having this kind of running alongside what I need to see in front of me, but on a slave screen that I can glance at when I need to, the ergonomics of that might work out really well. And that doesn't mean I'm saying that, again, tomorrow, in actual fact, we could be using this within these complex environments. But between Dean and I, what we've done is have really difficult conversations at a difficult time in a complicated environment to pave the way to see what might happen next. My last slide, I know we are shy of time at the moment, but my last slide is more than anything to say thank you to those people who really did want to collaborate at a tough time. I constantly rethink back to a time where I didn't know if I could research. I know many of you in the room would have thought exactly the same. It felt impossible. I recall having to resubmit ethics and just hope and pray that I could get it through on time. Without the clinical simulation suite and the center overall, without open-minded thinking from some of the surgeons who were under tremendous pressure, without time with Dean and his exquisite raft of students, the team at Drive, and perhaps most importantly, time and trust from Yvonne, I certainly wouldn't have been able to explore and uncover some of the opportunities that might present in the future for touchless computing. But all I feel is that it has been such a privilege, and I'm really excited about what the next few months have to offer. Thank you for having me along just to share a little bit of my part in the story. No, I was going to say, I think the next step, the next stage is actually the most exciting part, right? It's where you get to, that's it.
If anyone wants to try it out, they're here. So Amelia has been one of our lead architects in the latest version. Marcin has been working with the architect on the main code base, refactoring it. And Lil has just been amazing on the child play app, which lets you run in any game possible. Please do come up to them and have a go at the software. But any of you that are PhD students and looking at future research targets of this work, there are two really big projects that are about to kick off at UCL. The first is Hollow Repository 2023, which is revisiting our work from 4 years ago. And it's looking at a project called MONAI, M-O-N-A-I, which is sponsored by NVIDIA. And it's looking at how we organ segment. So the things that the surgeons were looking at with the CT scans. Our original Hollow Repository project that Sheena and I were on, we managed to go over several versions of it to go from a CT scan to a 3D holographic representation in 30 seconds. And that blew away all the hospitals that we showed them. And now it's touchless, and the next version of it will be out in September. We are looking at future research directions with that work. The other project that I'm extremely proud to announce with Sheena, under our IXN for Good work in terms of humanitarian systems, we have a collaboration with the Red Cross, the International Federation for Red Cross and Red Crescent, British Red Cross as well. First Response in a Box is about the future of technologies that can be deployed rapidly at scale to people on the ground when humanitarian disasters happen, and thinking about all of the interactions that they play, exactly based on Sheena's framework, how surgeons and clinical staff would manipulate things and work together with people. How do people on the ground get to work with others and combine their efforts to make first response actually happen faster? So if those research directions are of interest, please do let us know. Yeah, please do speak to our students and have a go at the software. Thank you.
Thank you very much for giving us just a taster of all the exciting and many projects. I think in the interest of time, we will forego the questions as we've got people to do through demos. And you also have on the ground floor, with seminars meant to finish at 4, but maybe shortly after that, celebrating someone who's got their PhD.
Yeah.
Well, thank you. Well, I think it's also as our traditional way of thanking for the lecture, the talk. We will have some drinks normally after the seminar, and happy to do that. My PhD has been approved, and I'm very happy to share the good news with everyone. Thank you.
That's amazing. I think we have tea, cakes, and other things downstairs in GO1, which is as you come in, it's just to the right or the left. Is that right? So, those, how do you want to run these demos?
You want us to situate it downstairs and people can come up while they're having their cake?
Excellent idea. If you take
Yeah.
it downstairs, then
Yeah,
we
that's
can
okay.
have tea and cakes at the same time.
You can burn off the sugar.
No, the same thing. Demo you're going to be giving so people know.
Yeah, of course. So I was working on Child's Play, which is trying to get children more kind of involved with their gaming through exercise. So it's using jumping detection and walking detection and hit triggers.
Right?
I'll be demoing remote touch so you can interact with the computer using different gestures commands.
And I've got facial navigation and speech commands. And we also have created a swimming environment where we're wanting to have children play and be a mermaid. So you can have a look at that if you want to be perfect.
And seeing as we're going to finish now, maybe we have time for other questions online.
Maybe.
Any quick question at all about what's been said, or we should go downstairs for a demo? What to do? Thank you very much again. I think it's really exciting. See how you're progressing with this and the different perspectives.
Thank you. Having that.